and I have the pleasure to co-host this new webinar related to our new development, which is called EDS for Extreme Duty Service. Frederick from Exponite, he will also do some presentation, and yeah, we are really happy to have all of you here to get this webinar. So this is the agenda today. So you will learn a lot about this new development that we have been working on for many years. So we get a lot of information about it, of course, and also some nice customer case for which we have used this treatment. And then at the end, I will do some kind of comparison with traditional ceramic valve. All right. So it should last 30 minutes, 25 minutes of presentation, and then 5 minutes of Q&A. So please, if you have any question, use the chat function, which will be at the top of your window. And also everything is recorded, so you will get a video, a link with a video later on. So no problem with that, and you will get also the presentation in PowerPoint. All right, so let's start. I will do briefly a short introduction about Ramén valve for those who do not know us, because it's a lot to discuss. So very quickly about Ramén. Ramén is a Swedish valve manufacturer for which we have production capacity in Sweden, and we produce control valve and process valve in Sweden. And this is our, let's say, our sales pie chart here. The main product that we provide is a bore sector valve, and that's something that we have created in the 1960s for the pulp and paper. So you see on the right part of the presentation all the technical features, but for those who don't know what is a bore sector valve, very quickly what it is, there is two main reasons why you may use a bore sector valve. The first one is the rangeability. A Ramén bore sector valve has a 300-to-1 rangeability, so you can use this type of valve for application where you have a big difference in flow. And the second one, which is of interest here, is for abrasive application, and that's why we use this type of valve for a lot of process industries, pulp and paper, steel plants, mining, chemical, food, for example, like coffee plants, sugar plants, and things like that. And obviously for abrasive application, we use already some kind of hardening treatment. So since 2022, we use super Exponite treatment, which will be developed by Frederick later on. And we have been using that instead of traditional hard chroming, because traditional hard chroming is forbidden in Europe since a few years. So we are not allowed to produce valve with hard chroming, and our customers are also not allowed to purchase product with hard chroming. So we have been successfully using Exponite since a few years, very much with a lot of success, and it's really performed as good as hard chroming actually. So the whole journey of this new treatment that we will develop started in this alumina plant, for which we supplied some control valves a few years ago. So this is on the right actually some information about what is an alumina plant. All of them are based on a Bayer process. So you see all the steps here, and basically you have what gets in is bauxite with caustic soda, and what gets out is alumina, which later on will be sent to aluminum plant to produce aluminum. So this is all the steps here, and where we supplied our control valve is actually at the bottom. You see this red mud to disposal pond. So this is a line where you get all this leftover of bauxite. So everything in bauxite, which is not alumina, and with a mix of caustic soda. And instead of being disposed, it actually goes to filters, because then you want to recover the caustic soda so that you can use it again in the process. But this filter need to be, controlled with flow. So you have this control valve, and you have all the process that are on the left, and you see it's kind of very hard application with a lot of solid content. You see up to 45%. Also kind of corrosive, because you have caustic soda, and with kind of a lot, let's say high delta P, because the outlet pressure is atmospheric. So it's a combination of corrosive, very abrasive application, and you have some high velocity also happening inside the valve with some possible, kind of high velocity. So let's move on. And this is actually the solution that we provided back then. So this is our model case 1E, and I will not go too much into details about what it is. But basically, our model case 1E is our bore sector valve, where we have hardening treatment on the bore sector and on the covering. In addition, we have a deep slide seat. So you see on the left picture at the bottom this special design, which is also unique in the market, that cover parts of the covering and protect it from abrasion. And also this type of valve is also used in reverse flow. You see on the right some picture. And the benefit of this is that, first of all, the ball sector valve is bidirectional, so it can control the flow in both directions. And the thing that to put it in reverse flow, so to have the seat facing the outlet, because of that, we have the vena contracta that is moved outside the body, outside the valve. The vena contracta is where you have the lowest pressure in the control valve system, and therefore the highest velocity. So if you have this vena contracta inside the body, inside the valve, then you have a high velocity, in that case also a lot of solid particles, and then you will completely destroy the body. So we just put it outside, the vena contracta is put outside the valve, and therefore the body is always protected. If you are interested by all these kind of features about our ball sector valve, we have very nice videos, 3D animated videos, available on our YouTube channels. So please make sure that you can have a look, and we have all kind of subtitles, so a lot of different subtitle language. All right, so that's what we provided a few years ago. This is the result after 1 month. The good thing is that the body was completely intact. That was the good thing. But you see after 1 month, some parts were completely damaged. So the ball sector, the seat holding ring, like the cover ring, and the seat. So that was obviously not good enough. And fortunately, we have a customer for which we have a very good communication with, and together we try to find solution to improve its lifetime, to make sure that we can improve, of course, the lifetime and investment for this type of valve. So we were thinking, okay, what can we do in that case? We know that there is obviously ceramic valve in the market, so why can't we make this kind of ball sector valve with a ball sector covering some parts in ceramic to increase the hardness, to make sure that it improves the lifetime? And then we were thinking, okay, we can do that, of course, but then obviously the cost, the availability will be much worse. I mean, the cost will be very high, kind of very long also to produce this type of valve. So we were thinking outside the box and to see what kind of other coating alternatives we can do. Because at the end, the idea was to increase as much as possible the hardness, to make sure that we can fight as much as possible the abrasion. Because to make sure there is no abrasion, we want to have a material which is as hard as possible. And this is where we came up with this new coating, because we tried a lot of different solutions, and this is the one that at the end we get the best result by far. And this is the one that we're actually talking right now and that we are releasing into the market. It is our EDS coating, that stands again for Extreme Duty Service. And it is a combination of several treatments, several hardening treatments that end up with a hardness of up to 5,000 becquerels. And you see on the left actually these different steps. So you see 3 ball sector. On the left, this is a stainless steel one. And then on top of this one, we put some super expandite treatment that already increased quite kind of a lot the hardness. And in addition of that, which makes this solution very robust, is the PVD coating, for which we can get up to 5,000 becquerels. So we do these treatments on all parts that are subject to abrasion, and this is obviously the ball sector, the cover ring that you see on the right, this cover ring, and also the seat. So the seat is also provided with EDS coating. All right, and now I think I will let Fredrik talk kind of in details about what is super expandite, what is the PVD coating. Yes, so I'll let you, Fredrik, continue.
Thank you. So, first of all, quick introduction. My name is Fredrik Albu. I work for Expedite in Denmark, which is a heat treatment company with a specialized focus on surface hardening of stainless steel, nickel-based alloys, and titanium alloys. So what it is we do is that we surface, if we're talking about surface hardening, we are improving the surface hardness on stainless materials. And by that, we also improve the wear resistance, galling resistance, and also actually for some alloys, increase corrosion resistance or maintain corrosion resistance in the material, which is one of the very special things that we are doing or having succeeded to do. There's also another benefit of the fatigue resistance is also increased. It doesn't say here on the slide. But if you go to next slide, there's a slide overview on the yellow. Oh, the yellow dot here explains what we do for Raméns as a treatment that we call super expedite, which is a combination treatment. And to give you a little bit image of what it is that we are doing for this super expedite treatment, it is in 2 steps. And the first step is called expedite high T, which is a process that's conducted in a vacuum chamber up in a high temperature up to 1150 degrees Celsius. In this step, we dissolve nitrogen into the material, and due to the high temperature, we have a deep diffusion of the nitrogen, increasing the hardness of the core somewhat, but actually have a reach of up to, it says 500 microns here, but for austenitic austenitic stainless steels, there is actually up to 1,000 microns diffusion depth. Once the diffusion has been done, there is a quick quenching with either nitrogen or argon to maintain this, to get a stable situation and no transformation of the material during cooling down. So we need to do a fast quench. If you go to the next slide, you can see the next process step that we are doing is called expedite low T. That is conducted in an oxygen-free environment, not vacuum, however, at lower temperatures, around 450 degrees. Can vary, of course. And this is a nitrocarburizing process where we diffuse nitrogen and carbon into the surface. The diffusion depth here is very concentrated to the surface and has a diffusion depth of, as a standard, 20 microns. We can play around with those depths a little bit, from 10 to 30 microns, but it's not recommended to go over 30 microns due to the compressive stresses that's built up in the surface. But 20 microns is more than enough in many applications. And in this case, or in this step, this is where we add the high hardness on the surface. As a standard, the hardness lies around 1,200 Vickers in hardness. And the case steps are, is around 20 microns. There is a new development on this side as well, called the expedite pure low T process, which is a totally different story, but this is also a process that's done as a standalone for austenitic stainless steels. A little bit more complicated, but the outcome is basically the same. Not all components are fitted are suitable for this expedite pure low T process, but it's been very successful for housings and also for fasteners and bolts and nuts and so on. But that's another story. So if you go to the next slide, the result of the super expedite process is, if when you combine the high temperature treatment with a diffusion of nitrogen deep into the material, but with a less hard surface at the end, but combine that with the expedite low T process, you get the super expedite, because then you have the high hardness with a diffusion depth of 20, followed then by another hardened zone, which goes deeper into the material, and then bringing a very nice and ductile situation on the surface and deep into the material. And the nitrogen in the material helps bring or stabilize the corrosion resistance in the material, and that's the general idea. But in some cases, it actually helps increase the corrosion resistance somewhat as well. And that's the main thing about Expedite. It is surface hardening, and there are many ways you can surface harden a component. But if it's made from stainless steel and you want to maintain the corrosion resistance in the material, you have to choose a method to surface harden that is that allows the corrosion resistant properties in the material to remain the same or actually improve them. If you go to the next slide. As Stefan mentioned, the hardness is 1200 Vickers in hardness, and it is a good replacement for example, hard chrome, which is less hard than that. But in other applications, such as the one Stefan mentioned, where there can be abrasive particles that have a higher hardness than the surface that we provide, you may need an extra layer of coating. I should also mention now, while I'm mentioning coating, that even though it sometimes looks as if Expedite, the super Expedite is a coating, it's not a coating, it's a diffusion. It's something that goes into the material stays the same, no buildup or anything. PVD, on the other hand, is a coating. It's a very thin coating, but it has a very, very high hardness and offers then a good protection for high wear particles in an application such as the one Stefan just showed you. So what is PVD? For those who don't know, PVD is a ceramic coating. It's a thin layer of metallic material that's deposited to another surface, and PVD actually stands for physical vapor deposition. It's performed in vacuum, it's nitride. So what I'll show you, I'll try to explain here. If you take a look at what I tried to illustrate as a disc, the one in the picture with the flashes going to it, that's called a target. Yeah, exactly. That's called a target. That can be the target material. It can be titanium, chromium, aluminum, or many other things. And that's the source where you take the material from. How do you do that? Well, you do it in vacuum, and then you, in this case, illustrated here, it's called an arc technology. You ignite a spark on the surface of the target, and through coils, magnetic coils, you get this flash, if you will, to jump around on top of this surface, bringing high energy in certain points to the surface of the material, actually sublimating the metal, where the gas is shot out into the chamber, where it's met with a plasma. The plasma consists of different gases, where you take nitrogen from. The atoms from the target will then combine with the nitrogen, forming nitrides. Just before that, however, it will become the atoms are ionized for a positive charge, and then it becomes nitrogen ions. So with this positive charge and a negative charge on the part that you want to have coated, the substrate that is, there will be an attraction of these positively charged ion nitrides on the surface, where they actually will condense like fog on a glass or something like that, but then freeze or become stable and hard. On the surface of the material, the material needs to be clean, of course, and have a good surface finish, but what you do is build up atom by atom. You build up a very, very dense and very, very hard layer of material. A commonly used PVD coating is a combination of aluminum and chromium nitrides, and the one which is actually the case for the one that Ramén is using, which brings a hardness level up to 5,000 Vickers in hardness. The thickness of a coating is no more than 3 microns, plus minus. You can make them harder, but not much. Sorry, thicker, but not much. So if you go to the next slide. So then why do you need an expedite? If you have this high hardness in the PVD coating, why do you need to do an expedite treatment on the part before you do the PVD? Well, stainless steel, especially austenitic stainless steel, is very soft, and it's actually way softer than recommended. Than is recommended for any PVD to be put on directly on the surface. It can be done, but especially when there is a case of elastic deformation, such as in this application that Stefan told you about, where there's a high velocity, there may be movement that is bigger in the material than is allowed for the PVD, and then you can have an eggshell effect, such as in the picture on top. So if you do a PVD before, or sorry, an expedite before, you have an increased hardness on the surface on which you can put an even harder coating on top. Illustrated as if you take a pane of glass and put it on a mattress and stand on it, it will break. But if you put between the mattress and the pane of glass a bit of plywood or something, you should be able to stand on it. That's the general idea. So you get a better load bearing for the material, that it can withstand impact much better. And choosing expedite for this is of course to maintain the corrosion resistance in the material, because as Stefan also said, it's highly corrosive, the environment where these ball sectors are. I think that was it for me.
All right, thank you, Fredrik. Then I will take over.
Thank you.
I will just try to summarize a little bit what we can provide at Ramén, so with our new EDS coating. And I think this is a good summary here in terms of harness. What can we provide? So remember that the standard material that we provide is stainless steel, and this is actually, as Fredrik mentioned, it's kind of a soft material, around 200 vickers. So you see the scale of harness, which is in vickers. So stainless steel is around 200 vickers, which is quite soft. Most of the ball sectors that we provide for abrasive application are provided with super expedite treatment, which, as Fredrik mentioned, around 1200 vickers, which is very hard already. It's 6 times more than stainless steel, and cover most of the case for abrasive application. But of course, we know, as this customer case we had, sometimes it is not enough. And there is obviously ceramic coated valves that are in the market and that are really hard, actually, much harder than super expedite or hard combing as well. But with the Ramén EDS coating, we can even achieve twice more than that, and we can achieve up to 5,000 vickers. So this is where we can actually provide a lot of improvement compared to what is in the market right now. And if you look at the customer case we had and that I mentioned before, so this is the result after 11 months. This valve now with EDS coating is still in operation. So we already have improved the lifetime by more than 11 times more. So from 1 month to 11 months, and it's still ongoing. We have a good communication with our customers, so we know exactly what is happening. So it is still ongoing, and we really hope that it's continuing like that many more months. So for us, it's really a very good customer case, a nice application that we have been very successful with this new coating. And we have also other ongoing tests at some mining plants, steel plant, and sugar plants. But obviously it takes some time to get results. So hopefully in a few next months, we will get more customer case to show you. All right. To end this presentation, I think it's time. So I will just make a small, let's say, some comparison with traditional ceramic valve, and I will make comparison with ball valve and butterfly valve with ceramic liner, which is mostly what ceramic valve are actually, and what Ramén ball sector valve with EDS coating can provide in addition of this ceramic valve. So first of all, the better controllability, because a ball sector valve has a very, it has equal percentage characteristics, so it is a very accurate control valve that can control between 10 to 90%, and that is, as I said, very accurate. It is used sometimes for dosing application where we need to control a few millibars. So the controllability of a ball sector valve has been proven for decades now, while while a butterfly valve can control between 30 to 50% opening, for example. So the controllability is much worse. So that's one thing. Then it is very much more cost effective. Roughly, a Ramén with EDS, Ramén ball sector valve with EDS coating will cost you around 10% extra cost compared to a ball sector valve with metal seat, which is kind of, let's say, cost effective if you compare to a product that will have been produced with ceramic parts, because then it will have been costly maybe 3 to 4 times more. So then we have an extra cost for 10% compared to 3 to 4 times more. So that is much more cost effective. Then it has much shorter delivery time as well. We say that a ball sector valve with this new coating can be provided within a few weeks. We have most of the parts in stock, and we use suppliers that are very nearby us. So a complete solution can be provided within a few weeks compared to ceramic valves that can be usually provided between, let's say, a few months. So all in all, then you see that the return of investment compared to ceramic valve are much better with a ball sector valve with EDS coating, and the availability as well is much better. Then of course, since the harness is much better, we have a similar or even better lifetime compared to ceramic valve. And of course, at the end, I think what is kind of important also for customers is to have a valve that is very easy to replace. Ceramic valve usually have a liner, so it means that if you start to get damage on the liners, then you need to change everything. A ball sector valve with EDS coating, you just need to remove these two screws that you can see on the covering. So then you remove the covering, and then you have access to everything that is inside the ball sector valve. So you can easily, within 1 hour, change potential damage parts like a ball sector or seat and the covering. So it's also very easy to maintain, and then also the cost of replacement is much less as well. All right, I think that's it for the presentation. So this is our email address if you have any question as well. As I mentioned also, you will get the video with the presentation later on. Yes, so I'm just checking also if you have any question quickly, otherwise there is, seems to. Just 1 second. All right, Frederick, do you see the question now? You are muted. So is PVD coating is permeable? You talk about how important it is to retain corrosion resistance in base material. The question is PVD coating permeable? If you go to the chat function.
Sorry. I don't know. I actually don't know what permeable means in English. That's a new word for me. But well, yes, I talked how important it is to retain corrosion resistance in base material.
I guess it means if the media can go through it, I guess. So if you can have some
yes. It depends a little bit on which kind of PVD coating it is, but PVD, a hard PVD coating is built up in columns, side to side like this, and it will eventually allow no PVD coating is actually a corrosion protection thing. Corrosion can occur under a PVD coating. But it actually protects. Sorry, it actually protects also from corrosion attacks, but it will never be a corrosion protection solution. There are some coatings that are more less permeable than others, but none of them is fully encapsulating of the base material.
Yeah, but I think it's a good question also. I would like also to add that the corrosion resistance is done here with the base material. So we have stainless steel and we have other material like 254 SMO, which are much better in terms of corrosion resistance. And the purpose of this new coating is not to increase the corrosion resistance, it's really to make it more resistant to abrasion. So that was the benefit of our coating. That's what I wanted to add some info here. All right, I have maybe one question on my side here, because I have some question from customers sometime. If we have we see some damage on the PVD coating, so we remove the valve, we see some damage on the PVD coating. Is it possible to send it back and do the PVD coating again instead of replacing parts?
Did you ask me now, or?
Yeah.
I didn't.
It's my question to you. Yeah.
Can you please post the question again?
The question is if you have damaged parts, you see that the PVD coating start to be damaged. Instead of replacing the parts, can we do PVD coating again?
You can.
On top of it?
Yes. Unless the base material is damaged, you can always reapply PVD coating on an already PVD coated part. It's fully possible.
All right, good. That's something that's beneficial as well. Instead of replacing parts, you can send it back to us and we do the PVD coating again, so that it's
yes,
it will work again. All right.
There's actually a question I can see if all European valve manufacturers, if they stopped hard chrome plating. That's a question also.
Okay, I was in the actually other chat here. Stop. Yeah, that's a good question, actually. We don't do it, and then if there is other European valve manufacturers that do use hard chroming, then they must have some kind of permission from EU, signed by EU with a deadline on it. Meaning that if a customer is buying parts with hard chroming, they must get this authorization letter from the supplier, stating that EU is allowing them to still use hard chroming for a short period of time. Yeah, so that's what I can say. It is possible, but customer need to make sure that they get this permission later from the EU, basically. I hope it answers your question. It's the same. So the thing is this is a EU rule. So if you have if you are a customer buying from China, or I mean from Asia, or whatever actually is outside EU, it is the same rule. So manufacturer having manufacturing side outside EU, they have the same. They need to apply the same rules. So they need to import in EU with something which is not with hard chroming. Right. Okay, good. No more question I see, but I hope you find this presentation interesting, and I think we can close the meeting now. Thank you, everybody.
Thank you.
Thank you.